Hi guys, I wanted to just make this video to go over a few of the normal calculation kind of things because it's super important. It's going to show up all year. Normal distributions are very important to statistics, let alone the class. And so I just want to make sure that what we're doing is super clear and that we understand what needs to be shown on a free response question, what kind of things I'm looking for on the test, and things that you always have to include whenever it's just a free response question and they're asking you to calculate a certain area or the inverse of that. So I have this example here about a tennis player named Rafael. You always want to just point out some of the important information. So they tell us the average is 115. So this is our mean, right? And then they also, if you read through a little bit, it says assume the distribution of his serve speeds is normal with a standard deviation of 6. So this is our standard deviation. And so those two things are super important. Also the fact that we know it's approximately normal or to assume it's normal. So this first part, it says about what percent of Nadal, Rafael's serves would you expect to exceed 120 miles per hour. So percent, whenever I see that word percent or proportion, I'm asking about an area under the curve. And it says we want the area that exceeds 120, so greater than 120, right? So the first thing is I'm going to draw my little normal curve. So this normal curve, you always have to label one the mean. So our mean here is 115. Our value of interest is this 120, so I'm going to put that above the mean because it's bigger. And I'm going to shade greater than 120 so that I remember and I show the greater that's what I'm looking for. I'm always going to label a normal curve with a capital N, mean, comma, standard deviation, always, always, always. So I'm going to be looking for all of those things on your little picture. The first thing, right, is that I need to calculate a z-score. I'm standardizing this normal curve. The reason being, right, is it would allow us to compare if we need to. It also, a lot of times questions will ask about the z-scores and the standard normal curve, and so you just want to make sure that you understand the process of finding a z-score and just practicing it always, always, always. So to find a z-score, you always have to write down the formula every single time. I'm already messing it up. You can write it in words or you can write it with the symbols. Just make sure that you're using the correct symbols always. So for us, right, that means I'm just going to plug in the stuff that I know. So x is the value, which is 120, minus the mean over 6. And so when you calculate this, you should put this in the calculator, you should get 0.833 about, right? So this is saying 120 is 0.833 standard deviations away from the mean, essentially. So what's happening, and I don't usually have you draw this one, but if it helps you, you can. So what I have now done is I have standardized. So now my mean is 0, my standard deviation is 1. That means I'm looking for values that are larger than 0.833. So this is called the standard normal curve. You'll see that verbiage a lot, so I want to make sure you understand what it means. The standard normal curve just means the normal z-score curve, right? They mean the same thing. So we have our z-score. We have to write our proportion probability statement. So it looks something like this. It would be the proportion of values that are greater than 120. So that's the area I'm looking for. I'm going to rewrite it with z because I'm using the z-score. So that's the same as the proportion of z-scores that are above 0.833. And so in the calculator, right, I would put normal CDF. And this is what the picture helps with. It helps with understanding the bounds and also how to write these guys, because they're super important and they're going to be looking for them. So I will be too. But whenever you use normal CDF, you have to label the numbers, what they are. You cannot just put numbers in the parentheses with commas. You have to label them. So we have the lower bound, just say lower, for us is 0.833. Our upper, I will usually just say 1,000,000, especially if you're using these z-scores. It's just a really large number, kind of a ridiculous z-score. Right, it would mean 1,000,000 standard deviations away. It's a really big number. Our mean is always going to be 0, and our standard deviation is always going to be 1 because it's a z-score normal curve. And when you put this in the calculator, you should get about 0.2024. So the question asked about what percent of his serves would you expect to exceed 120. We would say we expect about, so write it as a percentage, about 20.24% of, this is the context, of Raphael's serves to exceed, notice I'm just sort of restating what the problem said, to exceed 120 miles per hour. So you always want to get into a habit of actually answering the question, not just saying numbers. Sometimes they grade it like they're looking for this answer. Sometimes they're not. It's better to be safe than sorry, I always say. Just write that little statement for context and you're golden. Okay. So really the only difference with B is that now there are two values, two bounds, which means we have two z-scores we need to calculate. So I'm going to start it the same. I'm going to write my curve. I'm going to label it properly. And I'm going to put the mean here. Now just make sure that your numbers are relative to the mean. So 110 and 100 are both lower than 115. So I'm going to put them over here, assuming I can correctly label in order. So I'm looking for this area here, and I would shade it. Okay, so that means I need to find two z-scores. So I'm going to write the formula. It's x minus mean over standard deviation. So z1, this is going to be my lower bound. So that's going to be 100 minus 115 over 6. For my upper bound, it's going to be 110 minus 115 over 6. And so when you put those in the calculator, you should get negative 2.5 and negative 0.833 respectively. Okay, so then my probability statement is going to be like this: proportion of values between 100 and 110 is the same as the proportion of z-scores between negative 2.5 and negative 0.833. So this time I have an upper and a lower bound that I found. So I'm going to make sure my normal CDF statement reflects that. So my lower is negative 2.5, my upper is negative 0.833, my mean is 0, and my standard deviation is 1. And so when we put this in the calculator, we get 0.1962. So we would say we would expect about 19.62% of his serves to be between, and always include units if there are any, 100 and 110 miles per hour. So we answered the question. All right. And then the last thing is, what about when there's an inverse? How do I know I'm using the inverse? So here it says in a standard normal distribution. So we're talking about a z-score normal distribution. So that tells me two very important things. That tells me my mean is 0, my standard deviation is 1. That's really all that means. And so this question gave me a percentage. So they've given me an area and they're asking for the value. So that's how I know I'm using inverse norm. So I'm still gonna make a little sketch, right? Except here my mean is 0. I'm looking for the 20% above a z-value, so I'm gonna put it like here, right? And I know that this is 0.2, which means I also know, because you usually, almost always, you want to use the area from the left. So to find the area from the other direction, right, because the area has to add up to 1, the density curve. So 1 minus 0.2 gives us 0.8. So here, this area is 0.8. That's the area I'm going to use. So z, right, is equal to inverse norm, where my area, and you always label it, area is 0.8. My mean is 0. My standard deviation is 1. And so when you put that in the calculator, what do we end up with? We end up with a z-score of about 8.416. So this, right, this is saying that a z-score above 0.8416 is in that 20% range, right? So if I were to instead, right, if instead the question asked what serve speed is the cutoff for 20%, or how many observations, if 20% of the observations are greater than what serving speed, right, then I would just have to do a few more steps, right? Once I have the z-score, so instead if I was looking at this, right, so where my mean is 115 like we've been using, and I'm looking for this x value, right, the areas are still the same no matter what. So I can use the z-score formula and just work backwards a little bit. So I already have the z-score because I just found it. So I just replace the things I know. Don't forget to label your normal curves. I'm already forgetting to do it. Please don't do that. So my z-score is 0.8416. We don't know our value, but we do know that our mean is 115, and we know our standard deviation is 6. So then I just solve for x. I'll multiply both sides by 6. And so when I do that, you should get about 5.0497. And then I, of course, will add 115 to both sides, and you get 120.0497 as your value. So what this is saying is that 20% of, I guess I should say of Raphael's serving speeds are greater than 120.0497 miles per hour. Another way you could write this with 0.8, technically that means this is the same as the 80th percentile. I could also say, you always want to word it the way that the question was worded, but this is also the same as saying the 80th percentile for Raphael's serving speeds is 120.0497, that's not a 7, 497 miles per hour. Okay, and so those are just to give you some ideas of how to answer the question using the number. What does it represent? And I hope that helps. Feel free to scrub through this, rewind, speed it up, slow it down, whatever you need to do. I hope this helps. I'll see you when I see you.